talk about prime factorization. I do not teach least common multiple and I don't teach greatest common factor. I teach kids how to get to the answer using prime factorization. And at first it looks really difficult to kids and they have a hard time with it, but it really does end up being a lot easier. A prime number is a number that is only divisible by 1 and itself. So we say that 1 is not prime because it's not, 1 is itself. So we say it's not prime. 2 can only be divisible by 2 and itself, or by 2 and 1. So 2 is prime. 3, I can only divide 3 by 1 and itself. 3 is prime. Now 4 is divisible by 2, so that's a no. 5 is only divisible by 5 in itself, so it is prime. 6 is divisible by 2, so it is not prime. It's not divisible. 6 and 1, and it is also divisible by 2, so it's not prime. 7 is divisible by only 7 in itself, so it is prime. 8 is divisible by 2, and what you'll notice is any number that is in the 2 song or is divisible by 2, or it's an even number, cannot be prime unless it is 2. 2 is the only even prime number. 9 is divisible by 3. Ooh, that's an odd number, but it is divisible by 3. So we say it's not prime. 10 is divisible by 10 in itself, or 10 and 1, but it's also divisible by 5. So what you'll notice is 5 is the only one in the 5 song. Okay, so let's just get some of these in, and I will show you some of the rules here. This will be quick, I promise. I'm a quick writer. Okay. All right. So what I'm going to do is I'm going to cross out all these even numbers because they can never be prime. And none of these can be prime. Well, they're divisible by 2 also, and 5. So all these 5s are out. You see how that leaves me with so few? All right, so if it's in any, all of these are prime also. Okay, 21 is divisible by 7. 23 is prime. 27 is divisible by 3 and 9. So if it's in any math song that you've ever learned, then it is not prime because it's divisible. It's a multiple of something. 31 is prime. 33 is divisible by 3, so that one's not prime. 37 is prime. 39 is divisible by 3. All right, so we're left with 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. And that's what I tell kids to memorize, okay? If you're going to memorize primes, memorize 2, 3, 5, 7, 11, and then add these other ones on later, okay? 2, 3, 5, 7, 11, that's what we're going to use today. 2, 3, 5, 7, 11, and maybe 13. 13 might come up. So what we're going to do is use a factor tree. Okay, and it's going to get us down to the prime numbers. Now, I can use prime factorization to simplify fractions, and I have a video on that, so if you go look for it, it's in there. This one is 70, so let's do 70. Always start with 2. Is it divisible by 2? Now, it's divisible by 10. Okay, but I don't want to do that. I'm trying to get it to the basest fraction, the smallest numbers. So 70 is divisible by 2. 2 is prime, so circle it. What's half of 70? Oh, you don't have to know what's half of 7. Let's do that really quick. All right, I'm going to show you another trick. I'm going to divide all these by 2. Getting halves of odd numbers is easy if you think about it. Okay, so definitely, oh, I don't have to do this. I'm on paper this time. I'm usually on a board when I do this, so it's kind of habit. All right, let's finish since I started. Okay, 2 divided by 2. Half of 2 is 1. Half of 4 is 2. Okay? We know the even ones, so that's what we're going to do. So half of 6 is 3. Half of 8 is 4. Got it. Half of 3, okay, it's half of 2 and half of 1 because 3 is 2 plus 1. Half of 2 I know. Half of 2, well, half of 1 is 0.5. 3 or 2 and 1. Half of 2 is 1, half of 1 is 0.5. This is 1.5. And do you notice it's whatever's halfway in between 1 and 2? Oh, look. 0.5, 1. 1.5, 2. What's halfway in between 2 and 3? 2.5. What's halfway between 3 and 4? 4.5. What's halfway? Oh, and this is 10. So halfway between 4 and 5 is going to be that. So half of 70, oops, 3.5. 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. Okay, got it. This is also 10, 20, 10, 15, 20, 25, 30, 35, 40. We're just adding a 0 on the end. Okay, moving the decimal, if that makes sense to you. Another thing you can think about is 5 is 4 and 1. Well, half of 1 is 0.5 and half of 4 is 2, so this is 2.5. 7 is 6 and 1. Half of 6 is 3, half of 1 is 0.5. 9 is 8 and 1, so half of 8 is 4, half of 1 is 0.5. All right, so hopefully that helps you. I'm going to keep this to the side so that we can pull that back over. Half of 70 is 35, because if I have half of 7 is 33.5, half of 70, I'm going to just move that. So to get from 7 to 70, I move the decimal to the right. All I'm going to do for this one is move the decimal 1 to the right. Half of 700, I move the decimal 1, 2 to the right. I'm going to move this decimal 2 to the right and fill it in with a 0. Half of 700 is 350. Hopefully you understand that. All right. Okay, is 35 divisible by 2? It has to end in 0, 2, 4, 6, or 8 to be divisible by 2. Is it divisible by 2? No, it does not, because it ends in a 5. Is it divisible by, and I know this is divisible by 5. Okay, I know. But I need to go through and check these first, because in this instance it's not, but in other instances it will be divisible by 3, and I want these to go in order, okay? So 3, is it divisible by 3? 5 plus 3 is 8, and 8 is not in the 3, 6, or 9, and is not 3, 6, or 9, so it is not divisible by 3. And if you don't understand this, it's important that you understand divisibility rules, so go watch that video on divisibility rules. 5 is 35 divisible by 5? It is. 5 and 7, and 7 is prime. This is how a factor tree looks. Let's do 45. I know it's divisible by 5. I'm going to do my due diligence. Is it divisible by 2? No. 5 plus 4 is 9. And if it equals 3, 6, or 9, when I add like that, it is divisible by 3. So I'm going to start there. Think about a clock. 45 minutes on a clock. 15, 30, 45 divided by 3. There's 15 minutes in each section of the clock. And so 45 divided by 3 is 15. Okay, now I'm on 15. Is it divisible by 2? No. Is it divisible by 3? Yes, 3 and 5. Okay. And I will show you how to use this with fractions, to make fractions easier. 612, is it divisible by 2? I'm going to write those back up here. 612, yes, it is divisible by 2 because it ends in a 2. Now look, half of 600 is 300. Okay, taking half of numbers is easy. Half of 10 is 5, and half of 2 is 1, so this is 300. Oops, I'm going to write on the left. I just like to write my 2 here, my prime number on the left. All right, so this is 306. And if you really look, this is 300, and half of 12 is 6. Okay? Taking halves is going to be a lot easier as we practice this, okay? So 306, is it divisible by 2? Sure is. It ends in a 6. Half of 300. Oh, wait a minute. What's half of 3? 1.5. So half of 3 is 1.5. Half of 30 would be 15. And half of 300 would be 150. So half of 300 is 150, and half of 6 is 3. This would be 153. You see how that works? If you don't, use a calculator, okay? It will come, I promise, if you focus on it. If you're older, use a calculator. 153, is it divisible by 2? No, it is not, because it ends in 3. Is it divisible by 3? I would add 1 plus 5 plus 3 and see if it ends up being 3, 6, or 9. 1 and 5 is 6. 6 and 3 is 9, and 9 is 3, 6, or 9. If it is 3, 6, or 9, when you add them like that, it is divisible by 3. So it is divisible by 3. And this one I'm going to do a division problem for, because I can do it mentally, but I think I might confuse you. 3, can it go into 1? No, it cannot. Can it go into 15? Yes, it can. And I'm going to make sure I write that 5 directly above this 5. It's very important, because once you get into having decimals and things, it's going to matter. So if you start, how you practice is how you perform. So if you start now doing it correctly, it will become easier later. So I did not put it into 1, I put it into 15. So I'm going to put that 5 there, and I act like I have a little multiplication sign here. Steps to division are DMSBD. Doesn't my stupid brother look dumb? That's what they came up with in class. You can also do don't miss Sunday, bring donuts. There's lots of ways that you can remember this. We just divided, right? When he said I have 15 and I want to know how many times 3 goes into 15, and I said it's 5, that's the division step. The next step is multiplication. I act like I have a little multiplication sign up there because this is where the answer goes, but this is also what I'm doing. I'm doing 3 times 5 is 15. So if I had an arena with 15 people in it and I pulled 3 people out, how many times I would pull it out? 5 times. That's division. Well, then I got to figure out, well, how many people did I pull out if I pulled out 5? Okay, because sometimes it's not exact. This time it is exact, but we want to know how many people we have left in there, and we have 0 people left in there. Okay, and then I'm going to, that's the subtraction part. And then I'm going to bring down. If I have something to bring down, I'm not done. Okay, so this is 3, and 3 goes into 3 one time. If I have 3 people, how many times can I pull out 3? I can pull them out 1 time. And so 3 times 1 is 3, and then 3 minus 3 is 0, and I have nothing else to bring down, and so I'm done, and my answer is 51. Okay, 51, is it divisible by 2? No, it is not. It does not end in a 0, 2, 4, 6, or 8. Is it divisible by 3? 5 plus 1 is 6. And if it equals 3, 6, or 9, when I add them together like that, then it has to be divisible by 3, and it is. So 51 is divisible by 3. Let's do long division for that one too. 3 goes into 5. Oh yeah, if I have 5, I can pull out 3. How many times can I pull out 3? Just once, and I'll have 2 left over. So I'm going to put that 1 directly above the 5. That's my division step. Now I'm going to multiply. 3 times 1 is 3. If I had 5 people in a group and I took out 3, how many did I have left over? That's the subtraction step. 5 minus 3 is 2. Now I'm going to bring down my 1. 3 goes into 21 7 times. And 3 times 7 is 21. So I pulled all the people out. 3 times 17 is what I get. And if you look back at my list, wherever that may be, 17 is also prime. So that's the next prime number in this line, okay? So we're done. All right, so here's how we're going to use this now. Let's say that I have 76/112ths, which I don't know if you'll ever have that, but okay, so if I use prime factorization and I list 2 times 5 times 7. Now, first of all, 2 times 5 times 7, this is telling me that no matter how I put this together, these are the basest numbers that I can use to get to 70. So I can use 10 times 7, I can use 35 times 2, I can use 14 times 5, and all of them will get me to 70. Okay, so that's why we use it. And if you understand it, they don't teach it well enough in school, but I think kids do really well. I haven't had any kids really have a really hard time once they figured it out on how to use it. Okay, and so here's why I want you to do it in order with the 2 smallest, because if you don't understand this, it doesn't matter. Just see it. If I have something on the top and the bottom of a fraction, I can cancel it off of there. So first of all, what if I took this right here? This would be 2 halves times everything that's in here. And when I multiply by 2 halves, that's just like 1. So I can just cancel these off of here. Okay? And I have nothing else. There's nothing else here. Okay, so if I had, let's just say that I had a 3 and a 3, or I do have a 3 on the bottom. So let's say I have a 3 up here and I don't. But if I did, I could cross off another 3 off of here and get it to its basest number, the smallest number that it can be. Now, the only one I could take off was this one. That's the only one they had in common. So this is my answer. And when I give the answer, I'm going to give it like this. This is 35. And 17 times 3 times 3 times 2. Let's just do this. 3 times 3 is 9. 9 times 2 is 18. So 18 times 17 is what I would write on the bottom. All right, and this would be 306. Okay, so it doesn't make it a whole lot smaller. It only cuts it in half, so I would be dividing this in half. That's the only thing I could do because they're both divisible by 2. So like this is the other way you could do this. Instead of simplifying, you could do it this way, or I can say, are they both divisible by 2? Are they both divisible by 2? Yeah, they are. They both end in 0, 2, 4, 6, or 8. And if I do the same thing to the top and the bottom, I make an equivalent fraction. So I'm going to make smaller equivalent fractions. So 70 divided by 2 is 35, and 612 is 306, which I showed you earlier. So, yeah, that's as small as it can go. Let's see if we have another one. Let's try 88. Oops. Not that. Okay. Are they divisible by 2? Yes, divisible by 2. 44, divisible by 2? Yes, divisible by 2. 22, 2, and 11. Okay, so let's use this one and this one now. Let's do 88 612. This would be 2 times 2 times 2 times 11. And this one would be 2 times 2 times 3 times 3 times 17. Cross, 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 cross. And now I have 2 times 11 and 3 times 3 times 17. 17 times 9. Oops. Wrote faster than I spoke. 17 times 9 would be 63, 9, 10, 11, 12, 13, 14, 15, 153. 22, 153rds. Okay, so this is going to be the smallest I can get it. Okay, now 88 612. Let's do it the other way. Are they both divisible by 2? Sure are. This would be 44 and 306. Are they both divisible by 2 again? Oh, sure are. You see what I'm doing here? 22 153rds. And that's it. Now you can use it. There are some that work together, but these were just off the top of my head. But that is how you use it. This is why you will use it. And I just wanted to show you. So if you need more help on that, let me know and I'll make another video.